Hello everyone, we're discussing calorimetry and we have seen concept of mass specific heat capacity. Now let's also introduce the concept of latent heat. When we're talking about MSDT, you have water at 20 degrees Celsius and then you add some water which is at 40 degrees Celsius. When we go for this type of mixing, we use dq equals to ms dt alone. What is this? There is no change in the state of matter, liquid. So whenever we are using ms dt, remember, state of the matter doesn't change. Water and water. But what if you mix ice and water? You're mixing solid ice with liquid water. In that type of thing, what happens is something we'll understand with the help of latent heat. Now, first of all, what this latent or the term hidden is, try to understand this point. Suppose we have an ice cube floating in water. And the system is in equilibrium. At equilibrium, this is say 0 degrees Celsius. Water is at 0 degrees Celsius. Ice is already at 0 degrees Celsius. Now, at this equilibrium setup, water is at 0, ice is also at 0. Now, if you provide some heat to this system, then normally what we think, as we supply heat, temperature should increase. But that doesn't happen. When you supply heat to a system like this, temperature of water is not increasing. What happens? This ice melts. Normally आप यही सोचेंगे और वही हो भी रहा है that ice is going to melt. Now, as long as ice is present in the system, temperature is not going to change from 0. It's not going to increase. Temperature will increase once all the ice has melted. If you still supply heat, temperature will rise from 0 degree. But if ice is present, then this heat does not increase the temperature. So this heat, which is not increasing the temperature and is simply melting the ice, before we come to the concept of latent, let's also see another system. Look here. Suppose we have steam and water. Concept of steam and water. Water is at 100 degrees Celsius and you are providing heat. As we supply heat, this water vaporizes and becomes what? Steam. The steam is also at 100 degrees Celsius. Now, as you supply heat, you would expect that temperature of this water is going to increase from 100, but that doesn't happen. जैसे से आप heat दे रहे हो, water from liquid converts itself into gaseous state, which is what? Steam. And the more you supply heat, more it becomes what? Steam. But temperature all the time remains what? 100 degrees Celsius. Now, when the whole amount of water converts itself into steam and you still supply the energy, then temperature of that steam, temperature of that gas is going to increase. But as long as water is present, this 100 degree is not going to change. This 100 will remain same. Over here, when you supply heat, temperature of water is not going to increase. It will remain 0 degree throughout as long as ice is present in the system. So, the concept of latent or heat, it tells you basically what? We thought that something is coming, some heat is coming, but we found that no change in temperature takes place. So what people thought, that how come things are melting, water is becoming steam, but still temperature is not changing. To explain this, they use a concept of latent type of thing, that we are supplying some unidentified form of heat which is doing all this. Draw these figures and then we'll write few statements and everything will be clear once we see some examples. Draw this figure and also this, and don't forget to write that dq equals to ms dt is used when state does not change. Note down this much. Write down the statement. If ice and water are present in equilibrium inside the bracket at 0 degrees Celsius, and then some heat is supplied to the system, it is observed that temperature of water does not increase. It is observed that temperature of water does not increase as long as ice is present in the mixture. As long as ice is present in the mixture. Temperature of water increases once all the ice present melts completely. Temperature of water increases only when all the ice present in the system melts completely. Similarly, when water and steam are present in equilibrium, and heat is supplied, then it is found that temperature of water does not increase. All the heat supplied, all the heat supplied simply changes state of the matter. Inside bracket, from liquid to gas. It's only when all the water, it's only when all the water vaporizes and heat supply is maintained, temperature starts increasing. Temperature starts increasing. Which tells us that which tells us that it is not necessary that it is not necessary that energy received by a system must always increase its temperature. आपके पास एक बॉक्स के अंदर कुछ चीजें हैं, you have no idea what is inside, and you gave it some heat, and then you thought that temperature must increase. जरूरी नहीं है. If you were not told that inside the box you've got ice and water at equilibrium and you're supplying heat, then if you have a thermometer connected, you will find that that heat supply is not doing anything. You will assume what I'm saying. Again, put the whole thing inside a black box so that you cannot see anything inside. Connect a thermometer and you are looking at the temperature. Now, as you supply heat, you would expect what? Temperature is going to increase. But nothing like that happens. It's only when all the water, all the ice becomes what? Water, you find that reading of that thermometer is increasing. So this notion of heat and temperature, or in simple words, dq heat supplied and change in temperature, doesn't work with this type of thing. Now we study the whole thing in terms of latent heat. Now, as there is no change in temperature, then what that heat is doing? That heat is simply converting solid into liquid. That heat is simply doing what? Converting liquid into gas. And when it does that, we say that heat supplied Q is no longer ms dt, but is what? M multiplied by L. Or basically what was found, that the amount of heat supplied and mass of ice which melts, this ratio is always a constant. Energy supplied, and because of that energy supply amount of ice which is melting, this ratio is always a constant and is called latent heat of ice and water at 0 degrees Celsius. We'll write the value of L also, but in this you see there is no mention of change in temperature type of thing. So all the energy is melting mass M multiplied by L, which is called latent heat. This latent heat for ice and water is 80 calories per grams. What does it mean? If you need to melt 1 gram of ice, then how much energy is required? 80 calories. So this constant number is what? 80. For 1 gram ice to melt, heat supplied is what? 80. Similarly, L for water and steam, latent heat for water and steam is 540 calories per gram. That means if you got 1 gram of water at 100 degrees Celsius, then when you supply 540 calories, this 1 gram of water will become what? Steam. And there will be no change in the temperature. Temperature will remain what? 100 degree Celsius. Note down these values for latent heat for the ice and water and for steam and water. Remember, or you can also write like this, when you are changing from water to steam, your temperature is 100. Temperature is 100. There is no change in the temperature. I hope it's visible. And similarly, when you go for ice and water, latent heat for ice and water, your temperature is what? 0. For water, again it's what? 0. There is no change in the temperature. Do mention like this. Put down this much. Now, to understand the whole thing, let's just note down a question. Ten grams of ice, 10 grams of ice is mixed with 10 grams of ice is mixed with 100 grams of 100 grams of water, at 70 degrees Celsius. You've got 10 grams of ice and you mix this 10 grams of ice with what? 70 degrees Celsius water whose mass is what? 100 grams. Let's see if you can answer final temperature without my help. The hint is whatever we did with this type of equation, concept of conservation of energy, energy rejected, source, energy received, sink, they're always equal. So you have to follow that thing and then you can answer something like this. I'm giving you around 40-50 seconds. Let's see if you can solve this thing. Put down this question. Well, I've got only one response. Look at the technique. One is source and the other thing is what? Sink. Source and sink. Heat supplied or rejected, whatever you want to say. Heat supplied is coming from source and sink is going to receive the heat. Instead of equal sign, make an arrow like this, that heat flow will take place from source to sink. Source will supply some heat, sink will receive some heat. Now what is source? Thing which is at higher temperature. So this is your source. And this ice is sink. Now, when you supply heat, what basically happens? Look at this. Heat supplied, source, its temperature will decrease. If its temperature is going to decrease, why? Because system is not in equilibrium. Remember, this is at 0 and this is at 70. The things are not in equilibrium. So this 100 grams of water with specific heat S supplies heat such that temperature drops from 70 to T. T. Everybody knows that this T is going to lie between 70 and 0. 100 grams of water with specific heat capacity 1, temperature decreases from 70 to T. Always remember, from large temperature subtract the smaller value of temperature. This much heat does what? This much heat melts the ice. How much is the ice? 10 grams. To melt 10 grams of ice, you need what amount of energy? M into L. M into L. What is this? ms dt. अब लोगों को लगता है कि ये काम खत्म हो गया, इसने हीट दी, आइस ने रिसीव कर ली. But no, system is not in equilibrium. Water, 100 grams water, its temperature drops from 70 to T. This much heat does what? This much heat melts ice into water. What is temperature of ice? 0. What is temperature of water? 0. What is temperature of the final setup? T. So now what happens? This water, which water? The melt water. 10 grams of ice, once it melts completely. You get what? 10 grams of water. And this 10 grams of water with specific heat S increases its temperature from 0 to T. So heat is received by 10 grams of ice, but that heat supply is doing what? Part of the heat supply melts the ice, and then other part or the remaining part of that heat supply increases temperature of this melt water from 0 to the final temperature T. That's a one-line equation, solve it and you will get the answer. So this is ms dt. Why we are using ms dt? Because we are not changing the state water to water. We are using ml. Why? Because we are changing the state from ice to water. Again, what is this? This is water to water, and therefore we are again using ms dt. Water, water. Now when you solve this thing, you know the specific heat capacity of water. Mass specific heat capacity of water is what? 1 calorie. So when you put this value, you get S as 1, this is 7000. Minus 100 T, which is equal to what? 800. And this is your 10 ST. S is 1, 10 T. This is giving us 7000 minus 800, which is 6200, equals to 100 this side, 110 T, or your T is coming 620 divided by 11 degrees Celsius. If you understand every part of this question, then write down yes in the comment box. And if you have any confusion, then don't hesitate, ask anything. Write down next question. "100 grams of ice if I say simply ice, that means temperature is what? 0. 100 grams of ice is mixed with 10 grams of water. And this 10 grams of water is at a temperature of let's take 70 degree. This is the second question. 100 grams of ice is mixed with 10 grams of water at a temperature of 70 degrees Celsius. So find out final temperature. Find out final temperature or temperature when system is in equilibrium. Let's see how many of you will answer this. Only 2 have given any type of answer. And everything is same. What is the source? Something which is at higher temperature. That ice at 0 is same, everything is same as you see in the first method, first question. So what are the changes? I've simply interchanged their masses. This is 10 grams of ice, which becomes 10 grams of water, 100 grams of water, and that becomes 100 grams of ice. So do what? This is 10. This is 10, but this is 100. This is also 100. Hundred, 100. 10 grams of water with specific heat S. When supplies heat, its temperature drops from 70 to T. And this much heat supply is used by the ice first to melt it 100 into 80 and then change the temperature from 0 to T. And this equation, when you solve this equation, you get what? This is 1, so this becomes 700 minus 10T. On this side, you've got 8,000. This is 8,000 plus 100T. I hope you can see all the changes, which ultimately gives you what this is 10T, 110T. This is 8,000 minus 700, or 700 minus 8,000, which is basically minus of 7,300. So your T is coming minus 730 divided by 11 degrees Celsius. T is minus 730 divided by 11. And many of you have got the answer. Many of you have got the answer. But how many of you are comfortable with this? That this answer is not correct. There is nothing wrong in the calculation part as such. There is no silly mistake of plus and minus sign. Everything is correct calculation wise, but this answer is not correct. Why? Look here. Look at this requirement. If you are mixing ice and water, something at 0 with 70, your final temperature should lie between 0 and 70. और यहाँ क्या हो रहा है? टेम्परेचर कहाँ चला गया आपका? 0 के भी नीचे. क्यों चला गया? क्या गड़बड़ है? अब इसको समझते हैं. The thing is, well, before I tell you what happens, T is coming negative and I told you this is wrong. And who can tell me what is happening with this system? It's not difficult to figure out, because when I started today's lecture, I told you something like this only. I told you something about this only. The basic meaning of latent. is involved in this. Everybody who could not solve this thing, you have to note down everything, then make a cross, and then only you will understand what is wrong with this. Note down this much, make a cross, and if you can figure out what is wrong with this, that's really a good thing. The last answer I've got is the perfect thing, is the appropriate thing. This water source, 10 grams of water, is not powerful enough in terms of heat supply that it can melt total 100 grams of ice. Listen again. 10 grams of water, which is at a temperature of 70, doesn't have enough energy in it that it can melt 100 grams of ice completely. I'll explain this thing, but if I say this, that you don't have sufficient energy coming from water, that you can melt the whole amount of ice, then you can answer T in just 1 second and write down this answer. If you understand the statement, then you will be able to write T in just a second. Let's see how many of you can. Let me repeat my statement. अपने पास इतनी हीट नहीं है, बहुत सही, गुड. अपने पास इतनी एनर्जी नहीं है कि हम इस आइस को मेल्ट कर सकें. That means what? Ice is present. And if ice is present, then what is the temperature? 0. So you may immediately get to know that answer is what? 0 degrees Celsius. Now this is one of the good approaches for something like this. Once you get T negative, that means below 0, you will say that T therefore is 0 degrees Celsius. If you did everything correctly without committing any mistake in this part and you arrive at a negative value, then it tells you that T is what? 0. It immediately tells you that ice does not melt completely. Why maths is giving us a negative sign, मैं वो भी समझाऊंगा, but देखना यहां पर हुआ क्या था. Look here. How much ice we have got? 100 grams. This 100 grams of ice, to melt it, we need what? 80 calories per gram. If someone wants to completely melt this ice, then how much energy you need? ml. 80 into 100, which is 8,000 calories. To melt ice completely, how much energy you need? 8,000. लेकिन ये एनर्जी आएगी कहां से? ये एनर्जी आएगी इस वाटर से, इस वाटर से. अच्छा, ये वाटर कहां से कहां तक जा सकता है? मैक्सिमम. What is the temperature? 70. Max means on this side max. 70 से आप इसका टेम्परेचर कहां तक ड्रॉप कर सकते हो? 60, 50, 40, 30, 10, 0. 0 के नीचे नहीं. Why not? So if you drop temperature of water from 70 to 0, 70 to 0. In that case, how much energy will be supplied? If you are going to melt, if you are going to completely drop the temperature of water from 70 up to 0, the lowest possible temperature, then this water thing, it says M S 70 minus 0, which is 700 calories. Energy coming from water. When you drop its temperature from 70 to 0, is only how much? 700. अब कहानी क्या बनी? ये 700 दे सकता है और डिमांड कितने की है? 8000. You cannot fulfill the demand because supply is less, and therefore what happens? Whatever amount of heat is present to you, from that heat simply melt some amount of ice. Complete melting is not possible, and therefore since ice is present in the final mixture, temperature will be what? 0 degrees Celsius. I hope you understand what I am saying. Listen again. We have a heat supply of 700 maximum. This can be 70 minus 60, 70 minus 50, 70 minus 10, 70 minus 0. That's it. So you can get a heat supply of 700, but if you want to melt all the ice, then it should be 8000. You need 8000. लेकिन वो तो है ही नहीं हमारे पास. इसका मतलब जितनी हीट आपको मिल रही है उसमें से जितनी आइस आपने मेल्ट करनी है करो, बाकी बचेगी, और अगर बाकी बचेगी, that means finally temperature will be what? 0. Now, why maths is giving us a negative sign? मैथ्स को आपने क्या बोला? मैथ्स को आपने बोला कि भैया ये इक्वेशन है हमारी, somehow do something and make this whole thing correct. तो मैथ्स ने बोला ठीक है. मैथ्स ने क्या बोला कि आपको कितनी एनर्जी चाहिए? 8000. ओके, कैसे मिलेगी? मैथ्स बोलती है कि इस टेम्परेचर को 70 माइनस 0 कहां ले जाओ? ऑन द नेगेटिव साइड. ऑन द नेगेटिव साइड. Let's take this as 73 only, minus 73. Maths is saying what? कि आप इस टेम्परेचर को कहां तक ड्रॉप कर दो? 73 below 0. Which means what? मैथ्स बोल रही थी आपको कि आप क्या करना? 70 से पहले 0 लेकर आना, फिर उस वाटर को आइस में कन्वर्ट करना, और फिर इस आइस को और ज्यादा फ्रीज करना, और कहां ले जाना? minus 73. Do you understand what I am saying? You're trying to violate thermodynamics second law. Thermodynamics second law. You're trying to violate that law. कैसे? फिर से हमने क्या किया? हमने वाटर से एनर्जी ली, और उस एनर्जी को लेने के लिए हमने क्या किया? बिकॉज वाटर इज द सोर्स, तो वाटर से एनर्जी लेने के लिए हमने क्या किया? हमने उसका टेम्परेचर कम करना शुरू किया. अच्छा, हमने एनर्जी क्यों ली थी? हमने एनर्जी इसलिए ली थी कि हम वाटर से इस आइस को क्या कर सके? मेल्ट. अब काम का पॉइंट आने वाला है. वाटर से जो एनर्जी ली उससे हम आइस को क्या करना चाहते थे? मेल्ट. और हमने क्या कर दिया? हमने वाटर से एनर्जी निकाल कर उसको खुद क्या बना दिया? आइस. और उससे जो एनर्जी निकली, उससे जो पहले से आइस प्रेजेंट है, उसको क्या किया? मेल्ट. Which is what? Something that is not possible. कि हमने से यहां से ड्रॉप किया, ये नीचे गया, और फिर ये यहां तक आ गया. Which violates what? Second law. And that means whenever you find a negative sign, maths is simply telling you कि भैया किसी भी तरह से तुमको इक्वेशन सही करवाना है. Okay, take the temperature of the water to minus 73, because maths doesn't know what is the lower limit of this T, but you know that the lower limit is what? 0. tell me first, do you understand the whole explanation that how come this negative sign is coming and why final temperature should be 0 therefore? Do you understand the logic, the thermodynamics part and all? Are you comfortable with this? Yes or no? Fast. Good. Now write down the statement. Write down the reason why this thing is wrong. There is not sufficient heat present. There is not sufficient energy present in water so that it can melt all 100 grams of ice completely. Which means at equilibrium, ice is present in the mixture, and therefore final temperature will be 0 degrees Celsius. Now, you don't have to worry about that you will solve the whole thing and then you will figure out once you find negative and then you will be writing 0. You can straight away see the whole thing. Look at the amount of ice, 100. Heat required, simply calculated 100 into 80. This way. And then think about whether you can provide this much energy by taking temperature from 70 to 0, it gives us 700. So immediately say that, okay, sufficient energy is not present and therefore immediately you will tell us the final temperature is what? 0. In the previous case, things were what? In the previous situation, this was 10. So this was what? 800. So how much ice, how much heat was required? Only 800. This thing was 100. This thing was 7,000. This is 100. This is what? 7,000. Since this is 7,000, this is 7,000. That means what? You can get a supply of 7,000 joules. And out of this 7,000 joules, you need only 800 to melt, which is easily available. And then remaining portion will be used what? In increasing temperature. So by looking at the data itself, you can figure out easily what final temperature will be. We'll take some more questions on this part, but before that, for the same question, we have found that in the final mixture, ice is present. Now your aim is to get me how much ice and how much water are present in the final mixture. We have found that ice does not melt completely. So what amount of ice is present finally? Answer this. And what is the final amount of water? Look here. So we know that final temperature of the system is what? 0. Final temperature is 0. That means how much heat is coming? 10 grams of water with specific heat 1. Its temperature drops from 70 to 0. 70 degrees to 0 degrees. And now we know that this heat only melts a part of the ice present. Let's say that mass is m. We have no idea what this m is. M into 80. Whatever heat is coming only melts m mass of ice. So this is the melt water, which is m equals to 700 divided by 80 grams. What is m? जो ice melt हुई है. That means what is mass of ice finally? How much ice you had? 100. उसमें से कितनी मेल्ट हो गई? 70 by 8. What is the amount of water? How much water you had? 10 grams. How much is the melt water? This much is the melt water. 70 divided by 8. Add these two, you get COM, conservation of mass. There is no change in mass. इतनी ice melt हो गई, convert हो गई water में. Done. Note down this and then answer this. 100 grams of water, 20 degrees Celsius is mixed with 10 grams of steam. If nothing is given, then it means steam is at 100 degrees Celsius. So about 100 grams of water and 10 grams of steam, find out final temperature. Well, everybody is answering 100 degrees Celsius, 100 degrees Celsius. That means you're not comfortable with the concept. Look here. What is the temperature of water? 20. What is the maximum temperature? 100. Suppose you say that final temperature is 100. If you say final temperature is 100, that means what? This 100 grams of water, 100 grams of water with a specific heat of 1, you want to raise its temperature from 20 to 100, which is a requirement of what? 8,000. 8,000. If you are saying that final temperature is 100, that means this much heat is required. What is the max which you can get with condensation of this 10 grams of steam? 10 grams of steam, high temperature. This is the source. This source, which is at 100 degrees Celsius, can supply a maximum of M into L only. How much is M? 10. What is the L for latent heat for steam and water? 580, which is coming 5800. That means if somebody says that final temperature is 100, that means steam is only supplying 5800 and you need 8000. Not possible. And therefore, इस सिस्टम का टेम्परेचर पूरी प्रॉपर प्रोसीजर जो है उसको फॉलो करके ही निकलेगा. Those who are saying 100, 100, 100, almost everybody is saying 100. I don't know why. But that's not the way you answer the question. In just 10 seconds, you can find that 100 is not the correct value. So what do you need to do? heat supplied, heat received. Heat supplied, heat received. What is that which is going to supply heat? Definitely steam. How much is that? Steam is 10 grams. When it completely converts itself into water, how much energy you get? I wrote 580, this is 540, but even then your nothing changes, argument remains same. This is not 580, this is 540. But still the argument is valid because this is less than what, 8000. So this is 540. What is 10 into 540? We're using ml. What is this? This is steam to water conversion. What is this? This is 100 degrees Celsius to 100 degrees Celsius conversion. From gas into a liquid state. Then what? We need something over here. Heat is received by what? Heat is received by 100 grams of water with specific heat capacity 1 and temperature is increasing from 20 to some final temperature T. 100, 1, T minus 20. Which means you are saying that finally water is present. Which means you are saying that this 100 degrees Celsius of water which you get after the condensation of steam must again supply some heat in this form. 10 into specific heat 1 and then 100 minus T. What is this? This is water to water. What is this? T to or T, 100 to T. 100 to T. What is this? This is water to water. Water which was initially present at 20 is now present at T. Source is what? 10 grams of steam. First, its temperature remains same, state changes. Then, state remains same, temperature drops. The amount of heat coming from this side is used by the sink, which is 100 grams of water. Its temperature increases from 20 to T. Solve this and you will get your final answer. So what is this all thing? This is 5400 plus 1000 on this side. This is 20 and this 100, 2000. Shift there. And this is coming what? 100 T plus 10 T over here. 10 T T is coming 8400 divided by 110. That's the answer. So all those who gave 100 degrees Celsius and those who did nothing, are you comfortable with this answer, yes or no? Answer this. 20 grams of steam plus 100 grams of water at 80 degrees Celsius. 20 grams of steam, 100 grams of water at 80 degrees Celsius. Find out final temperature. Well, you're taking quite a long time. Look here, how easy this thing is. If you, let's say a final temperature is below 100, steam is at 100. So if somebody says that temperature drops from 100 to, let's say, 90 or something, 90, 95 or something like that, then it means first complete condensation took place. So if complete condensation took place, then the amount of heat which is coming out from the steam is m into L, 20 into 540. Which is 10,800 calories. अगर पूरी की पूरी स्टीम कंडेंस भी हो जाती तो इतनी हीट चाहिए थी, इतनी बाहर आती. This is available. If only steam changes from 100 degrees Celsius to water at 100, इतना मिल जाता. This water says if you increase the temperature from 80 to 100, if you want to increase the temperature to the maximum, even then it only requires this much, 2000 calories. So water says it only needs this much. If you want to increase the temperature from 80 to 100, that means what? That means complete condensation of steam doesn't take place. That's it. आपको चाहिए कितना था? इतना. अगर आप पूरा 100 तक लेकर आ रहे थे वाटर को, तब इतना चाहिए था. और अगर स्टीम को आप पूरा का पूरा वाटर में कन्वर्ट कर देते 100, तो इतनी हीट मिल जाती. दैट मीन्स क्या हो रहा है? ज्यादा आप हीट सप्लाई कर रहे हो, रिक्वायरमेंट ही नहीं है. Which only tells us complete condensation of steam doesn't take place. And if complete condensation of steam does not take place, then it means steam is present. And if steam is present, then you know that final temperature can only be 100 degrees Celsius. Final temperature can only be 100 degrees Celsius. In just one line you can answer this. In case you could not figure out this and you start with this same approach which we did, source, sink. If you try that and you solve the whole thing, for this particular data set, your T will be coming greater than 100. You can try that. Use the same ice to water, then water to water, and then on the right side, if you go with that approach, when you solve it, your T will be coming 100. And if somebody did try that, they would have found that T is coming greater than 100. Not possible. Because maths, again, is trying to violate second law. मैथ्स क्या बोल रही है कि स्टीम ने अपने अंदर से एनर्जी दी और अपना खुद का टेम्परेचर 100 के ऊपर ले गई ना, हो ही नहीं सकता. So what is the final temperature? 100. Why? Because heat available with steam is very high. Water को उतना चाहिए ही नहीं. And then you can easily answer how much heat is present, how much steam is present, and how much water is present. अपने को पता है कि this 100 grams of water only needs 2000 calories. Now look here fast. This 100 grams of water only needs 2000 calories. So how much steam should become water? M into what? 540. What is this? Water says if you want to increase my temperature from 80 to 100, why? Because final temperature is 100, then n grams of ice, its condensation should take place. With n grams of ice, not ice, steam. How much is the energy supplied? M into 540. So this is giving you M, which is 2000 divided by 540 grams. What is this M? जो steam क्या बन चुकी है? Water. So how much finally steam is present? 20 थी तुम्हारे पास, minus n कर देना. This is steam. How much water is present? You had 100. And additional you get after the condensation plus n. What is final temperature? This is coming 100 degree Celsius only. If you understood everything in this example, then write down yes in the comment box and then you can leave. Thank you very much.